Critical Thinking Rule 21. Expect complexity. Rule 21 is about causal complexity. There are at least 5 different kinds of causal complexity. 1, when you have multiple causes producing an effect. 2 is when you have to distinguish between the relative weight of different causes. There's multiple causes, but they don't contribute equally to the effect. 3, if you have nonlinear relations between cause and effect. That means that for every given increase in quantity of the cause, there may be a different increase in quantity of the effect. 4, dynamical systems means the nature of the causal connection can change over time. 5, feedback loops. This is where when the cause produces the effect, there can be another step which reduces the cause. This can be either positive or negative feedback. An example of a complex causal system is the carbon cycle. This, for example, involves multiple causes, nonlinear relations, dynamical systems, and feedback loops. Let's start with multiple causes. This is when more than one factor contributes to the effect. There are 2 main types of multiple cause situations. 1 is when multiple factors produce an effect separately. 2 is when multiple factors produce an effect jointly. For example, if you want to think about developing lung cancer, there can be different factors that produce that effect separately. Smoking might be one, inhaling asbestos or some other particulate could be another. Let's look at the example of smoking in more detail. Let's look at this sample argument. Smoking does not cause lung cancer. Many people who smoke never get lung cancer, and many people who get lung cancer never smoked. So the claim made in the second sentence of this argument is true. Not everyone who has lung cancer is a smoker. Not every smoker gets lung cancer. However, this is overlooking several types of causal complexity. One is that lung cancer can be caused not just by smoking alone, but smoking in conjunction with other factors. Just because not everyone who smokes gets lung cancer, this does not mean that smoking does not cause lung cancer. Smoking causes lung cancer because it increases the probability that you will get lung cancer, even if it doesn't guarantee it. In order to get lung cancer from smoking, you also have to have other factors present. And these could include things like your genetics and other environmental factors that affect your physiology, the physiology of your body. So also the fact that not everyone who gets lung cancer is a smoker does not prove that smoking does not cause lung cancer, because there can be other causes, such as inhaling asbestos, of getting lung cancer. Let's next discuss the issue of relative weight of different causes. This is referring to how much each cause contributes to an effect. For example, suppose someone reasons as follows: the sun is contributing to global warming. Therefore, humans' contribution to global warming is insignificant. So even if there are multiple factors besides humans' pollution or other human activity that contributes to global warming, that doesn't tell us which factor is the most important. It's a separate question. So don't think that just because there are multiple causes, that therefore means one cause is less important. A third type of causal complexity is nonlinear relations. This is when the relation between 2 variables is curved, not linear, i.e. does not have a constant slope if you plot it out on a graph. Here's an example: the relation between eating apples and your health. It's not the case that the more apples you eat, the healthier you get at a constant rate. So if you eat 1 apple a day, that may be better than eating 0 apples a day. But if you eat 100 or 500 apples a day, then that's not going to be a constant increase in health for each additional apple that you eat. And there's a variety of reasons for that. One is that apples, like many other foods, have compounds in them that are healthy or non-toxic at low doses, but at high doses can be toxic. So apples have a small amount of cyanide in them. I think it's present in the seeds. Eating a small number of apples is not at all bad for you. It's actually good. But if you were able to eat a large amount, it could have a toxic effect. So nonlinear relations means that a given amount of the cause doesn't always produce the same amount of the effect. It depends on how much of the cause you have, where you are on the curve if we were to graph it out. A dynamical system is when relations between the variables changes over time or under different conditions. An example is the dynamic relation between the fish population and the lake size based on the time of year. So there is a general correlation and also a causal relation between the size of a lake and how many fish live there. Having a larger lake causes a larger fish population. However, there's not a constant relation between these two factors because it can change over the course of the year based on the seasons, how much food is available to the fish, their breeding season, etc. Finally, there are feedback loops. This is when factors can mutually causally influence each other. An example is the relation between eating, blood sugar, and insulin. So if you are hungry and eating, this increases blood sugar. When blood sugar increases, your body secretes insulin. Insulin causes the cells of your body to absorb the sugar. This decreases the amount of sugar in the blood. When blood sugar gets low enough, then your body secretes other hormones that stimulate your appetite, causing you to engage in eating behavior, which then causes your blood sugar to increase, and so on. So in other words, there isn't just a one-way relation between these variables. They interact with each other over time. Next up, we're going to look at a practice problem making an argument for causation.